Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, this is a video for chapter 8, random variable. Okay, random variable is kind of mixture of between probability and statistics. Okay, so now we are into chapter 8, random variable. Okay, so random variable can be divided into two types. First can be called as discrete random variable. Another one is continuous random variable. Okay, so for now we will only be looking at discrete random variable. Okay. Random variable is a variable whose value depends on the outcome of a random experiment. Okay, for example, we have an experiment of tossing two coins. Okay, our example is tossing two coins. Okay, the sample space in tossing two coins are head head, head tail, tail head, and tail tail. Okay, this you already know about this, about random sample space. Okay, so what is called as random variable is something that we set that we want to focus on in the experiment, and we call the random variable as x. Okay, x is the random variable, and x is the number of heads appearing. Okay, so since x is equal to the number of heads appearing, okay, so now let's focus on our sample space. So how many times can the head appear in our experiment? Okay, our first outcome is head head. So from here we know that the head appears two times from here, and then head tail appears one time, tail head appear one time, and tail tail no heads appear, so the appearance is 0. So then we can say the random variable are 0, 1, and 2. Okay, this is the number for random variable. So random variable is a real number. It depends on our x. So since our x want the number of heads appearing, so then we count the number of heads appearing from our sample space, and we found out that there could be 0 head appear, there could be only one head appear, and there could also be 2 head appear. Okay, this is a sample example for random variable. Okay, so let's go into discrete random variable. Okay, discrete random variable is a random variable that assumes countable values. Okay, discrete random variable is a random variable that assumes countable value. For example, x equal to number of students. So that we can count student as 1, 2, 3. There is no 1.5 number of student. There are no 1/2 number of students. Number of student can only exist in the term of full number 1, 2, 3, and so on. for continuous random variable, is something that involve decimal points. For example, weeks or height that involve decimal points. Okay, so let's focus on discrete random variable for now. Okay, inside discrete random variable, okay, this is discrete random variable. We will be looking at probability distribution. Okay, okay. For example, the example that I have shown you before, the tossing of the two coins, the sample space are head head, head tail, tail head, and tail tail. Okay, from here we found out that the random variable of x, which represent the number of heads appear, are 0, 1, and 2. Okay, from here we can form a probability distribution table. Okay, so let's the first row represent the x. Okay, this is the x, and then the second row is the probability of x to appear. Alright. Okay, so our x, we have 0, 1, and 2. Okay, so the px is the probability for 0 head to appear. Okay, since the x is 0, so the probability of 0 means the probability of no head that appear. So since there is only one tail, so there will be only 1 over 4 the probability of no head appear at all. Okay, then for x equal to 1, probability 1 means the probability of only one head appear. So for only one head appear, it represents these two outcomes. These two outcomes equal to 2 over 4. That means 1 over 2. Okay, so the probability written here should be 1 over 2. Alright, and then the probability for x2, probability P2. So means probability where 2 heads appear, only one outcome. So that is 1 over 4. Okay, so this is the probability distribution table. Alright. So one extra information, actually random variable is also a kind of a function. Okay, it is also a kind of a function. So from this table we can form our function where f(x) is equal to 1 over 4. Okay, 1 over 4 is where the x is equal to 0 or 2. Okay, this x actually represent the capital X of our random variable. Okay, our capital X is equal to the smaller x that will be used inside the function. Okay, when fx is equal to 1 over 4, then means the input will be either 0 or 2. Okay, we can see from here, when the input is 0, the output is 1 over 4. When the input is 2, the output is also 1 over 4. Alright, so the function is equal to 1 over 2 when x is equal to 1. Okay, can be shown right here. When x is equal to 1, the function will come out as 1 over 2. Alright. Okay, so then we have 0, that means the otherwise. Alright, okay, now let's look at the characteristic of probability distribution function. Okay, so now we know that the probability distribution function is also one of a kind of, it's also a kind of a probability. So since it's a probability, so p x that represents the probability of the distribution function can exist in between 0 or 1 only. Okay, from 0 until 1, because it's a type of probability. Okay, and then the summation of all of the probability of x will be equal to 1. Okay, so that is just the basic one. That's just the same thing as the probability that you have learned before. Okay, so now let's look at a few kind of simple calculations that involve random variable and probability distribution. Okay, based on the same table, the same experiment of tossing two coins. So let's say if we want to find the answer for probability of x equal to 1. Okay, question number 1, find the probability of x equal to 1. Okay, we focus on inside the bracket. It mentioned that random variable is equal to 1. Okay, so since the table shows the random variable equal to 1 is equal to 1 over 2, so then the answer is equal to 1 over 2. Okay, alright, then question number 2, the probability of x bigger and equal to 1. Okay, so means it wants a probability that is equal to 1, probability for random variable that is equal to 1 and bigger than 1. So we refer on our table, we only have 1 and 2 that is equal to 1 and bigger than 1. So that is just equal to probability of x equal to 1 plus probability of x equal to 2. Okay, probability of x equal to 1 is 1 over 2 plus probability of x equal to 2 is 1 over 4. So our answer is 3 over 4. Alright, question number 3, probability of x less than 1. Okay, probability of x less than 1 is only for random variable x equal to 0, because it doesn't want x equal to 1, only value that is less than 1. So equal to probability of x equal to 0, and that is just 1 over 4. Okay, question number 4, probability of 0 less or equal to x or less equal to 2. Sorry, probability of 0 bigger or equal to x or less than 2. Okay, no equal right here. Okay, so equal to the probability of x equal to 0 plus probability of x plus equal to 1. So x equal to 0 is 1 over 4 plus 1 over 2 equal to 3 over 4. total all of this 1 over 4 plus 1 over 2 plus 1 over 4, so they just equal to 4. So that follows our second characteristic, where the summation of probability x equal to 1. Alright, so now let's form a graph based on the outcome, based on the table. Okay, if you want to draw a graph, so the px will be located on the y-axis. So this is the probability of x. Probability of x, because it is the outcome, and then x is the random variable. Px is the probability. Okay, then on the x-axis we have 0, we have 1, we have 2, ataupun x lah kat sini. Okay, then the probability is 1 over 4, 1 over 2, or 3 over 4. So when the x is equal to 0, the probability is 0, and the probability is 1 over 4. When x equal to 1, probability is 1 over 2. X equal to 2, probability is 1 over 2. Okay, just make a line, and that is the graph for the probability distribution function. Alright, now let's look at an example. Okay, the above table show the probability distribution of the number of 6 employees per week. Alright, okay, so based on the table, the first row, the number of 6 employees per week, represents the random variable where the x equal to 0, 1, 2, and 3. So the probability is probability of x equal to x. Okay, so question A1, find the probability that the number of 6 employees at a given week is 1, 2, 3. Okay, A1, so probability of 1, 2, 3. So 1 less bigger than or equal to x, or less than or equal to 3. So this means from 1 to 3. So this one, it recovers from probability of x equal to 1 plus probability of x equal to 2 and plus probability of x equal to 3. So equal to 0.25 plus 0.30 and plus 0.35. Then we have the answer as 0.90. Okay, for question A2, more than 2, so means probability of x bigger than 2. So when x bigger than 2, only means probability of x equal to 3. That is just 0.35. Okay, then for A, 3 less than or equal to 1. So probability of x less than or equal to 1 means from 0 until 1 only. So we get the probability of x equal to 0 plus probability of x equal to 1. So that is 0.10 plus, and then we have 0.35. Okay, and then for A4, question number 4, exactly 2 means probability of x exactly equal to 2. So that is just 0.30. Okay, then for B is to represent the probability distribution graphically. So we first draw the axis, probability of x, and this is the x. So the x is from 0, 1, 2, and 3. This is 0.1, 0.20, 0.30, that is the graph. Okay, next question. We have 3 fair coins are tossed at the same time. Let the variable x be the number of heads appearing. Okay, mention the random variable x equal to number of heads appearing. Okay, now if we have 3 coins and then we toss the coin, the sample space that we have is actually equal to 3 head, head, tail, head, head, tail, tail, head, tail, and tail, tail. So these are the outcomes that we can get when 3 fair coins are tossed. Alright, so from the coin itself, the probability of getting a head is equal to 1 over 2. Okay, and then the probability of getting a tail is equal to also 1 over 2. Okay, so now we can form the table. Okay, this is the x, and then the probability of x equal to x. Okay, the random variable that we have, number of heads appearing. So the number of heads appearing, there could be 3 head appear, 2 head appear, or 1 head appear, or no head appear at all. Okay, so that's mean our random variable is 0, 1, 2, and 3. Okay, and then the probability of getting 0 head appear means all 3 are tail is 1 over 2 from the 1 over 2 of tail plus 1 over 2 plus 1 over 2, because there are 3 coins. We have tail, 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 so that is why here are 3, 1 over 2, 1 over 2, and 1 over 2. So total we have the probability is 1 over 8. Okay, probability of sorry, this is not plus but multiply. This is a multiplication. Okay, 1 over 2 times 1 over 2 times 1 over 2. Okay, so next is the probability of only 1 head that appear. Okay, 1 head that appear means 1 over 2 from the head multiply 1 over 2 from the tail multiply another 1 over 2 from the tail. Okay, since there are 3 times or 3 ways of only 1 head to appear, so then we have to multiply this by 3. So then we have the probability is 3 over 8. Before, where there is no head appear, there is only 1 possibility for it to appear. So that is why we only multiply it by 1. Okay. Next is 2 head appear. So 2 head appear, we have 3 ways that it could appear. So the same thing, 3, 1 over 2 from the head, also 1 over 2 from the head, and another 1 over 2 from the tail. So equal to 3 over 8. So 3 here appear. So that is 1 over 8. Okay. So this is the table probability distribution. Alright. So next is that show that x is a discrete random variable, and hence write down the probability distribution function. Okay. How to prove that this random variable x is a discrete? So we take all the total possibilities or the total outcome. Okay, we calculate it like this. Probability of x, the random variable, from less or equal to 1 or bigger or equal to 0. Okay, so we have to do this calculation. Means equal to probability of x equal to 0 plus x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. So then we have 1 over 8 plus 3 over 8, 3 over 8 plus 1 over 8. So then we have 8 over 8 that is equal to 1. So by this we have shown that x is a discrete random variable. Okay. So next is the probability distribution function. So to write down the probability distribution function, we write down the fx that represents the function. Okay. How many kind of outcome do we have? We have 1 over 8, 3 over 8, 3 over 8 and 1 over 8. So there are only two kind of outcome, two kind of probability. There is either 1 over 8 or 3 over 8. So the input from the 1 over 8 is where x equal to 0 and 3. Meanwhile, for the output is 3 over 8. The input x must be 1 or 2. Alright. That is the probability distribution function. And then this is the probability distribution graph. Okay, so this is the graph. Okay, for 0 is equal to 1 over 8, 1, 3 over 8, 2 also 3 over 8, and 3 is 1 over 8. So this is the answer. Okay, next example is to show that function fx equal to x squared over 55 for x equal to 1, 2, 3, 4 and 5 is a probability distribution function of a discrete random variable x. Okay, so we are given with a function fx equal to x squared over 55, and the x could be x equal to 1, 2, 3, 4 and 5. Okay, so this is the random variable. This is x equal to x, and this is the output. Okay, so in order to identify, we have to do a calculation, give all of the value of x, place it into the function, and make sure that sum of the function is equal to 1. Okay, so take the summation of function and we place all of the value of x that we have. 1 square over 55 square over 55 plus 3 square over 55 plus 4 square over 55 and plus 5 square over 55. And then we calculate this and we have the total number of function is equal to 1. Okay, so from here we can already prove that the probability distribution function is a kind of discrete random variable. Okay. Okay, then for question A is to find the probability where x is equal to 3. Okay, so when x is equal to 3, x come from this value, x 1, 2, 3, 4 and 5. So that's mean we take it just equal to x, we input it inside the function over 55, and then we have the answer as 9 over 55. Okay, for B, where the probability x is bigger than 2, so bigger than 2 means probability of x equal to 3 plus probability of x equal to 4 and plus probability of x equal to 5. So 3 square over 55 plus 4 square over 55 plus 5 square over 55, and then total is equal to 10 over 11. Okay, for question C, probability of x less than equal to 4 means probability of x equal to 1 plus x equal to 2 plus probability x equal to 3 and plus probability of x equal to 4. 1 square over 55, 2 square over 55, 3 square over 55. Okay, so we have the total answer is 6 over 11. Okay, so let's I want you all to try to do the question D, probability of 1 less than x less or equal to 5, and question E, probability of 1 x or less than equal to 3. Okay, so now you can pause the video and try it by yourself. Okay, then the answer for question D is 54 over 55, and the answer for question E is 14 over 55. The next question example is to find the probability distribution from the given probability distribution function. Okay, so we have to be cautious right here because the input and the function, the equation of the function, output of the function is different. Okay, make sure you use the correct output with the correct input. Okay, so the first thing is to show that P is equal to 1 over 31. Okay. In order to prove that one, we already know the total summation of probability will be equal to 1. So in order to do that, we take summation of Gx. So that will be G input 0 because we have x0, 1, 2, x3 and 4. So G0 plus G1, the input, G3 and plus G4, and it will be equal to 1. I miss one function here, plus G2 okay, so 2p1, so just mean equal to 2p plus 2p2 and plus p3 square. Okay, this one is p3 px square. We use this one. Okay, starts from x equal to 3 and x equal to 4 and plus 2 sorry, not 2 but p4 square equal to 1. So this is equal to 0, 2p plus 4p plus 9p plus 16, p equal to 1. So 31p equal to 1, so then p is equal to 1 over 31. Okay, so that is how we prove that p is equal to 1 over 31. Okay, next for question A. For question A, probability where 1 is bigger or equal to x or less than 4. So that's mean if we count the probability from px equal to 1, px equal to 2 plus px equal to 3 only. So px equal to 1 is 2. 2 over 31. Px equal to 2 is 4 over 31 and plus 9 over 31. So we have answer 15 over 31. Okay. Okay, for question B, the probability where x is bigger than 4. Okay, so since our input x has no value bigger than 4, so then the probability is just equal to 0. Okay, so then for question C, probability where modulus x minus 3 less than 2. Okay, so we need to remove the modulus and it will becomes negative 2 bigger than x minus 3 less than 2. Okay. Okay, then we calculate probability 1 less than x less than 5. So that covers from p x equal to 2 plus p equal to 3 and plus p x equal to 4. So it counts from 3 over 31 plus 4 over 31 and plus 16 over 31 and equal to 29 over 31. Alright, for question D, probability where the x is equal to 1.5. So the same thing, also we didn't have any input value or any random variable at 1.5, so this is just equal to 0. And then for question E, where the probability x is less or than or equal to 3. Okay, please try this out by yourself. So it recovers from probability x equal to 0 plus probability